Hello everyone, welcome to the next tutorial 1.4.1 Electronic Solar Cell Simulation. At my previous video 1.4, I have already discussed about solar cell simulation and their optical behavior and active layer thickness variations. In this video, it is a second part of the video, so I will be discussing at here electrical behavior of the solar cell. So we will be simulates at here all the electrical properties. So firstly start of my video, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Our company also have partnership with Nano Academics, which is Canada-based company. They offer several softwares like Nano Decals, which is used for the material and device simulations. Second one is Rescue, it is used for the material simulation. Third one is KittyCat for the spin solid qubit simulations. It is a Matra, which is USA based company for the simulation of cloud based materials. And Fluxim, it is a Switzerland based company which offers several softwares like Setfos. Our company offers several services like software distributor, training program, technical supports and equipment, and also microprobe stations, solar cell, thin film, FET, gas sensor, transistor and memristors. Company also have valuable customers like IIT Madras, IIT Guwahati, IIT Dhanbad. Several of customers are present. As my previous video, you can already seen it. Who has not seen it, please check out the playlist because I have already give detailed discussion about the company and their features and also the Setfox software and Fluxim company. So it is a very brief description. Now we will be discuss about the solar cell simulation. In this previous video 1.4 tutorial, I have already told about the solar cell simulations. So it is a second part of the video. At here we will be simulate electronic solar cell simulation and electrical parameter we will be discussed at here. At the similar layer we will be create in here and we will be active drift diffusion module. So now I will be move towards the Setfox. Click at the right side and run as an administrator. Who has not seen it my previous video, please check out. I have already told about the Setfox software and their features. In here I will be discuss about the only electrical parameters. It is number of the examples we have given at here. As my previous video, at here the similar layer structures are created and absorption settings and shift settings I have done. If you want to create the another file you can create, and otherwise if you want to active the drift division, so all the drift division parameters you can give at here. The better understand is I will be create new file. Click at the add layer. So number of the layers you can add. As previous video, similar layer structures one by one we will be created. Air top, glass, ITO, pedot, PCBM. One more layer you can add it here, aluminum, air, bottom. So you can see that here the solar cell is surrounded by air, therefore we create new name as air tops and air bottoms. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. I have already told that things a lot of times. Now you will be give the thickness. 100. For aluminum, you will be considered 500. Thickness as per your choice, you can change. It totally depends on you. So layer structures are created at here, but we need to import the refractive index files that supported .nk file format. That layer structures which is wavelength dependent, so we will be imported refractive index files that supported .nk file formats, and one by one we will be imported their files. So for the ito.nk file format, we will import their files. For the pdot, similarly we will be imported their file. For the p3ht, similarly imported their file. And aluminum. So we have imported refractive index.lk file formats file. Glass at here incoherence because thickness generally is not much needed at here. Unit will be changed at here micrometers. K will be selected at 0. Discretization points we will be selected at 100. I have already told about the discretization at my previous video, so you can check what is the meaning of the discretization elements for the H&M calculations. We need to active absorption module for the setting of the absorption parameters. So at here you can change 300 to 900. ITU for the internal quantum efficiency, it will be selected at 0. As my previous video, I will be variate thickness at here from 10 to 250. Size can be 5 nm. You can give name at here solar cells and run your simulations. So you can see at here the results. But we need to calculate at here electrical parameters because it is a part of the first video. So for the electronic solar cell simulation, we need to activate drift fusion modules. In this section, we will be learn the optical and electrical behavior of the bulk electrode junctions organic solar cells. This tutorial generally based on the previous optical simulation in the solar cells. So at here, to couple the generate charge with drift fusion equation, so need to activate the drift fusion modules. So at here P3HT PCBM as a active layers working. So we need to at here mention the top and bottom electrodes. So PEDOT acting as the electrode 4.8 and aluminum we activated at the general tab 4. It can be injection model ohmic. It is boundary condition. Work function is 4 electron volts. Between the top and bottom electrode, we need to activate semiconducting layer. If you want to calculate electrical behavior, you need to import semiconducting layer file. It will be electrical mechanical file formats supported. So you need to import .am file format for the P3HT PCBM.am file. At here the drift fusion settings, we will be click at here mode. It is a steady state For the general tab, you can see at here electrical source voltage 10, temperature you can change if you want 300 Kelvin. When the absorption and diffusion modules are active, so optical and electrical behavior automatically couple and the charge or excitation generation is given by the optical absorption profiles and generation efficiency of the charge or excitant. To activate the optical generation of the charge carrier in P3HT PCBM layer, we set optical generation efficiency 0 to 1. For the layer structure, you can move at here. You can see at here optical generation efficiency. In order to compute JV curve, shift setting need to activated. So at here we need to update and P3HT If you are taking voltage, so ranges is considered -1 to 1 and steps 0.1. We need to sweep at here because if we are sweeping both of the parameters, so firstly we will be sweep voltage. If you not put the voltage above sides, then any value above the voltage, it will be automatically considered sweeping. So we need to put the voltage at the above side in the sweep parameters. You can give at here new name and start the simulation by pressing the run button. You can see at here the photo currents. It is a total device currents together with the recombination losses as function of applied voltage. Power conversion efficiency also given at here and power density. You can explore various electrical profiles in the simulation with two or more parameters. One by one, band diagram, charge density, charge generation, current, electrical field. If you want to play this, you can easily click at here. X-axis and Y-axis ranges are given. For the charge density, you can also play how that it can vary. You can see at here. For the N, for the P, recombinations and potential. It is absolute residual error, iteration, residual error. So passive optic properties are also given at here. For the absorption, it is here laser absorption. You can simply click at here the play button, reflectance, straight contribution and transmittance. Here the key figures also given: open circuit voltage, short circuit current, fill factor, maximum power density. So you can check out here all the value. It is a current balance and voltage graph are showing at here. So I hope you will get my points electronic solar cell simulations, and if you have any query about this simulation you can ask in the comment section, and also my emails are given, and you can also check the website impulsetechnology.in. You can book our demo for more details. Thank you very much.